A very good evening. I greet to my lecturer, Mr. Halim, and to my fellow friends. Today, I'm going to present my seismic wave and imaging technical review presentation for January 2022. First of all, I'm going to introduce myself. My name is Isaac Ahmad Andria, and with ID number 16002521, and I'm currently in my final year, third semester, and the topic that I will present today is about diffraction migration. My main content about my presentation today is, first of all, we will start from introduction, and then follow up by background of study, follow up by problem statement, the analysis, which including the issues of currently presenting about my topic, the conclusions, and last but not least is recommendations. What is diffraction migration? Diffraction migration is the penetration of wave energy into the areas of the bending of wave energy around the obstacles, which are explained without obeying the Snell's law as explained in the Huygens principle. It occurs when a seismic wave encounters a heterogeneity without a clearly defined tangent plane, such as an edge or tip, and the reflection part of the ray theory breakdowns. In this topic, we will mostly discuss more about the diffraction stack migration. For my background of study about diffraction migration, for a good diffraction seismic result, we will need to migrate the diffraction to its points or origins, which is a process commonly known as migration. Not doing so will lead to a mispositioning errors in estimating oil location or reservoir, which results in many dry holes and reservoir or well. This diffraction stack migration is closely related to Kirchhoff migration. For the problem statement, we assess various factors which affecting the seismic data quality and particular imaging issues facing in oil and gas industry. Second, we want to develop a critical thinking capability while gauging the level of comprehension and the research ability about diffraction migrations. And last but not least, we want to understand and utilize the ability to evaluate the advanced seismic imaging techniques which are currently being developed and used in the oil and gas industry. The analysis part of the diffraction migration is that our goal in seismic imaging is to use the seismic data to create reflectivity sections of the Earth in either XZ or XYZ space. If the reflection traces are all we have, how do we want to identify the XZ point as the origin point of reflections and migrate them to their reflection point of origin? We can see this on the figure on my right side, where the off model on the top left and the idealized zero offset seismic section on the top right, where each trace was recorded by an experiment where the source has zero offset from the geophone. The above ZO seismic section, represented by data, roughly resembles the Earth reflectivity model because we unrealistically assume it contains only the primary reflections and the reflection in the data originate directly beneath the trace. There are two types of migration that we will focus on the diffraction migration today, which is one of it is post-stack migration and the other one is pre-stack migration. So I will explain about post-stack migration first, where the migration procedure can be automated by smearing reflection energy along a fat circles where each donut is filled with the reflection wavelet. For a single trace input with a single impulse value in time, the migration response of the above code is known as the impulse response. The impulse response are used to test the fidelity of a migration algorithm where the actual ZO impulse response in a homogeneous medium should be a circle, and any departure from that is a cause for concern in a numerical migration operator. As we can see on the figure, there was a fat migration circles for the top homogeneous, and in the bottom there was a inhomogeneous velocity medium. The source wavelets will fill in the fat circles. For my second part about the diffraction migration is about pre-stack migration, where in a complex medium such as beneath a salt dome, the enable and stacking assumption is inappropriate, so that the stack section is too blurred and so cannot be well imaged by the post-stack migration previously. To cure this problem is to eliminate the NMO and stacking steps where we can perform pre-stack migration on the short gather, where the recorded on a horizontal recording plane, the source and geofence coordinates for a short gather. We can see this from our figure on the right side, where in the top the stack section and the bottom is the post-stack depth migration sections, which how truncate the reflectors have been shortened and the deflections shown have been reduced by migrations. Moreover, reflections with conflicting dips or the events with the same arrival time but different dips have been relocated to their place of origin along the interface. For the migration operator for multiple arrivals, the migrating of many types of events with different arrival angles to their common reflector points leads to a better resolution, where at that point there will be a cleaner migration image. From a pattern matching point of view, the complicated pattern of the primary plus multiple migration operator will correlate well with data only in a small neighborhood of the actual scatter point. Thus, the image resolution is very good. The disadvantage of primary multiple migration is that its migration image is especially sensitive to errors in the migration velocity model. Small migration velocity errors will tend to give a noisier image compared to the primary migration image. Moving on, I'm gonna explain about the issues that we will encounter for diffraction migration. How does one choose the trace and short interval as well as the total recording aperture? The issues that we're gonna encounter is the trace interval is selected so that the discrete representation of the data still contains unambiguous information about dips. Second part is that the steeper data dips and the higher source frequencies will demand finer trace spacing. Also, steeper dips in the model will give rise to ZO reflection rays that are almost horizontal, so that it will demand wider recording apertures. As we can see on the figure on the right side, where there was a migration of left primary on my left side, and on the right side is the primary plus multiple reflection energy by diffraction state migration of the data. The solid curve represents the migration operators for different trial image points, which are represented by the field circles in model space. The primary plus multiple migration operator associated with the black trial image point will provide the best correlation between the dash data and the black migration operator. In conclusions, diffraction migration can be viewed as either smearing a time sample of data along the corresponding migration, where circles or ellipses, or equivalently, it can be viewed as summing energy along the appropriate hyperbola and dumping it into the pixel center for a fixed trial image point at X and the source receiver point. Last but not least is about recommendations of diffraction migration. A wide-angle reflection will allow for the capture of steeply dipping specular reflections. The diffraction stack formula is acceptable when there is a plenty of redundancy in the data, such as high fall. but the obliquity factor should be used if the fault is low. Therefore, it is rarely used today for subsoil imaging. A digital anti-aliasing filter should be applied to the data to eliminate operator aliasing. Unlike the depth migration, time migration does not suffer from the migration stretch but does suffer from mispositioning of events in a complex geologic areas. However, the velocity model must be finely tuned in order to get depth imaging to show a coherent section. This, compares to time migrations, will usually provide a good looking image because the stacking velocity is used to estimate the time migration velocity. The stacking velocity is robustly estimated by efficient and automatic velocity scans, while the velocity model for depth migration is typically estimated by time-consuming and tedious process. That's all for my presentation today. Thank you for listening.